Yeah, so we are recording now. Hi, everyone. I'm happy that you are joining this call. I was excited for it. I mean, the main reason for me to do this call, basically to clear up some confusion regarding some topics that our team has been working on, and also to get to help the new team members to get up to speed and updated with a lot of the concepts that we are working on in the cells and decomposition. For example, like we are doing the decomposition now, me, Tong, and Rutger, we are working on that to bring it to self-managed, which is something different than what, not so much related to the cells, something we discussed in the previous call as well. So yeah, I wanted to give you a summary about what our team has been working on. Basically, that's the previously called Sharding team, and at some point it was called the pods team. Over like our work, to show our work over the last 1 year and a half. I might skip over some topics, mainly because I also joined GitLab and the team in the middle of that project, so I might not be familiar with the order of the events. I might not be expert in some topics as well, and some topics are not relevant so much anymore, so I'm going to skip over them because I feel there's some important stuff that we need to focus on more. Around 1 year ago, GitLab, basically the application and the workers and the many components of the system were connected to one big database cluster. Okay, when we say database cluster, we mean database master node, one in the middle. I don't know, do you see the mouse as well when I move it over the, yeah. So this is the master node. This is the one that's receiving writes. It's the only node where we can write stuff, but we read from the other replicas. We also read from the master node. Okay. Sometimes when we see there's some replication lag, for example, you update some user, you don't want to read the same user information from a replica where it's like you read the old information. So you still need to read it from the master node. You consider like the size of the data and the size of GitLab.com. Everything is written to the master node, but everything is replicated to the replicas as well, because this is how database streaming replication works. You cannot choose which tables you want to replicate. Everything is replicated. With that said, you can imagine how much of a problem this is for us. Like I think we have in this documentation page, one of them, like about the sizes of the table. So you can imagine how much work this is for the database reliability team and the SRE team. For example, every time we upgrade the operating system or the database to some new version, we have to copy all this data to a new server, okay, and then do some, like we have to go down for a while, and then so with this big database, you imagine how big problem that is. Even if you have replicas, it's still big problem to have this all in one database. Some of you might ask, like, okay, why don't we partition the tables? So this is something that came up recently with the events table. Like the events table is causing some load on the database. Yes, we can take some big tables and partition them, but they are going to stay on the same database. So all the problems that we have with the storage, at some point we are going to reach some highest limit of storage for any database. So the data is not going to fit there anymore. So partitioning the tables is not going to solve that problem. It might still solve the problem with the load on the database. And also the problem with the partitioning is that you have to go into each table alone and see how the access patterns on that table and partition based on that table. We have discussed that for the events table. Should we partition the data monthly or yearly or weekly or whatever? Imagine doing that for 150 tables. I think we have even more. In theory, you can put some partitions on some other nodes that might solve the problem, but this is still so much work for just one table. And we wanted the solution where we can get the value like much higher, like benefits from the effort that we are doing. That's why the decision was eventually to split the tables, our tables, between two database clusters. Again, it's clusters, so each cluster has one master node and replicas. And in order to do that, we have to take our tables and split them into groups. Okay, one table group is on one database, the other is on database 2, and some tables have to sit on both, they have to exist on both databases. Most of these tables are mainly for technical stuff rather than business stuff. For example, users are going to stay on database 1, projects or CI pipelines are going to be on database 2, but for this, we call them shared tables. It's for some topics. We are going to talk about them later. Any questions so far? Cool. So the decision was eventually left to call the first database 1. Main database, and the second database is going to be called CI database. The idea was that we have a lot of tables that are called CI underscore, or they belong more to the CI part of GitLab. So we decided to split these tables based on that. So any table that's used on the main database, it will fit into something called GitLab schema, called GitLab main. And any table that fits into the CI fits into the GitLab schema, GitLab CI. This should not be confused with table schema that's on database. Databases, they have something called table schema, which is called public by default. GitLab schema is something different. GitLab schema is something that we came up with to decide on which database this table should be. So if you see these names, okay, at least now you have some idea about what they mean. So that was the.
I have a question. At the moment, we have main and CI, but do we have at the moment right now GitLab share?
Yes. We have few tables that I don't have the names here. I can tell you one of them. We are going to talk about it in later slide. Something called foreign keys deleted records. Okay. I will show you that later. Okay. These tables basically are written to and used on both tables. Okay.
Databases.
Sorry.
On both databases, not tables.
On both databases, yeah. But the idea as well is that if a customer or any setup has one database, something that we still support, all of these tables are still on that one single database.
Maybe adding to the prior one, you may be asking why not PostgreSQL schema. There is a historical reason for that. We do not establish a schema that our customers can use. So they use all over the place. They have public, they have their own schema. So we couldn't use PostgreSQL schema. And GitLab schema is basically an application level PostgreSQL schema. Mm-hmm. Effectively. Yeah, this is the whole purpose of the GitLab schema. It's an application level PostgreSQL schema because we couldn't do PostgreSQL schema because customers have it all over the place, and we could not ensure that public is a common name, and we could not ensure that we have permissions to create new ones.
Yeah. So in order to prepare for this decomposition later, I cannot move the slide now. I can. Okay. So one of the biggest problems that we have is that these tables, any GitLab main table, users, and any GitLab CI table, CI pipelines, they have a lot of foreign keys between each other. So we had to remove all these foreign keys between them. Foreign keys have benefits, of course, to make sure that any record that's pointing to any other record in some other table, that other record exists. If we delete some record, some other children records also are going to be deleted. This is the first problem. The other problem also, we were doing queries that involve joins between two tables. So this is something that both of them needed to be removed. The foreign keys needed to be removed, and also the queries needed to be rewritten. This is something that was also done before I joined, but of course I knew about it about these problems because we already have a lot of code to detect these problems. This is something that needed to be done on one database before we even created another database. There was also, of course, another problem. It's more complicated than that. Other problem was we have some database transactions that involve GitLab main and GitLab CI table, and this is something we needed to get rid of because the point of a database transaction is we have one unit of fork that needed to be on a database. Sorry, and if there's some problem that happens, we need to do rollback. But if these two tables that they belong on two databases, transactions cannot give us this guarantee anymore. So that's why our code has to detect any problems, any tables that are modified from two categories, GitLab main and GitLab CI, and tell the developers, hey, you need to rewrite this. This is not valid anymore. I can give links for this if any engineers want to go through this code. So how did we solve the problem with the foreign keys? Again, foreign keys, like all the join queries, we rewrote them. So we solved this problem. But foreign keys, they give us some benefit, which is like if you delete let's say you delete some project, all the pipelines of that project are going to be removed automatically with the foreign keys. But if you don't have the foreign keys anymore, what do we do? That's why we have some component called lose foreign keys. Basically, what it does is that anytime a record is deleted, okay, it's going to schedule that all the children of that record to be deleted later via Sidekick. So this deletion is not going to happen immediately. It's going to happen later via Sidekick. So if we have a lot of jobs to be processed with Sidekick, we had some incident 2 weeks ago that Sidekick had a lot of jobs and there was some problems on GitLab.com. These records might be deleted later, maybe 10 minutes, 15 minutes later, but it's not a big problem. They are going to be deleted eventually. So this is the job of the lose foreign keys. And Arthur, this is what also answers your question. We track all the deletion via table called lose foreign keys deleted records. Because the deletion can happen on the main database or on the CI database in both directions, this table is written on both databases. And if you have still single database, this table only exists in one database. But again, it's GitLab shared. So it's not classified as GitLab main or GitLab CI. So that's basically it for the lose foreign keys. We have something else also that I thought like it would be worth sharing, especially for the organization and all the work that has been done on the projects and groups. Something also I think Alex is very familiar with when he watches the recording later. So even though we had to remove all the joins between the queries, namespaces and projects and groups, they have a lot of joins involved in them because there's a lot of permissions and business logic. So it was really hard to rewrite that. So to rewrite these queries without joins. For example, can a user view some pipeline, or can a user view some CI component or something without doing join on namespaces and project? It would have been really difficult to rewrite that. The idea was that let's take the namespaces and the projects and let's mirror subset of their information to the CI side. Okay, just information that's only needed for that. And this is why we have something called CI mirroring for only two tables at the moment, namespaces and the project. So every time one of them is deleted, updated, or we insert new one, we are going to make a copy of that on some table called CI namespace mirrors, CI project mirrors. Even that's the idea. Even if we have single database, we are still doing this mirroring here. We have a whole page written about that. We don't only mirror them, we also check the consistency from time to time that everything is fine and there's no problems, and we correct this data in case there was any problems. Any questions so far? Cool. This project has been done in phases. I hope I'm not going to run out of time. So this project has been done in phases. The first phase was like we create another database cluster. So again, that's another cluster that has its own master node. But in this case here, this master node is also a replica. So basically, this replica in the beginning, we just created it and it was not used. It's just to prepare that for the split later. And then later in phase 3, I don't know, I forgot like what was done exactly in phase 1 and phase 2. I just merged them together. So I might be skipping some details here. So in phase 3, to make use of this replica, I mean, we have some nodes there that we are paying money for that. So we thought, okay, now it's time to start reading anything that's related to GitLab CI. If we need to read from these tables, let's use this new database cluster for it. So only for reading, we were doing that on the new cluster. But writing, for example, if you want to write new CI pipeline or anything related to CI, we are still writing it on the original cluster because the new cluster is only read replica. So, and then what we did later in phase 3, that was phase 3, yeah. What we did also in phase 3. I think that was almost the time when I joined GitLab. So again, something I might miss some details. We introduced some component called PG bouncer between the application and the database. Many of you might be familiar with the concept of PG bouncer, this component that it handles the connection from application. Every time the application scales up or down, this component is like handling the logic of connections from database so that the database cluster itself does not have to deal with connections. So we are taking some work off the shoulders of the database. But this is not the main benefit we are like taking from the PG bouncer. We will see later that with the PG bouncer, it's going to be easy to switch the connection from one database to another. And that's why we introduced this component later to prepare for phase 7, we will see, which is the most important one. So
can I ask you a question, because I'm confused? Like maybe it's the previous slide that we don't have the. So we have the main cluster and CI cluster, right?
Mm-hmm.
And then inside we have GitLab main and GitLab CI on each. So yeah. What is that like? Because we have main with GitLab main and CI with GitLab main and GitLab CI.
Yeah.
So I'm confused about that.
Yeah, let me clarify. So in these phases, any phase before phase 7, okay. So you can imagine the main cluster here is like, let's say 8 nodes. One of them is the master node and 7 replicas. And also this one here is one master node and 7 replicas, but still this is also a replica. This whole cluster is a replica actually. All the nodes contain the same data. Everything is like, if GitLab.com is 100 gigabytes, every node is containing 100 gigabytes the exact data. It's going to be, maybe there's some replication lag, but it's the same data. So we have to do all the writes basically on the main. They are going just to be replicated everywhere else. So we are still writing on the GitLab CI tables here.
Okay, yeah. So I thought before that we have a real separation now in place, but at the moment it's not, because we are like in the middle of the transition, right?
Yeah, I should have clarified this. Anything before phase 1, it was just classification of tables. There was no separation yet. So it was classification of table and just removing the joins and the foreign keys between them. Okay?
Well, yeah, thank you.
Yeah, so we reached a point where we have PG bouncer. PG bouncer basically receiving all the writes. Every read, it's still going through the replicas. I'm not sure here. Maybe Camille can correct me. Like the replicas, they don't have a PG bouncer. The PG bouncer was only for the writes. If you still remember, of course.
PG Bouncer is mostly used for connecting to primary because it's like a connection puller. So
Yeah.
basically, it's like a multiplexing. One of the biggest thing that is like constrained resource is like how many connections can an actual database accept at the given moment.
Mhm.
So PG Bouncer basically multiplex. I don't know what is the number, but like I guess we have a few thousand connections to the PG Bouncer, but only a few hundred to master. So basically, there is like a mix of the PG Bouncer plus Patroni. Patroni is basically electing. First of all, like our cluster consists of many equal Postgres servers. Basically, they all maintain basically the same data. Patroni is electing which of these nodes is writable at a given moment. And we simply use PG Bouncer to connect to writable node. For replicas, I believe we connect directly to those nodes. Patroni basically publish information about nodes that are replicas, and we simply fetch these nodes that are replicas from service discovery, and application maintains connection directly with them. So we've been using PG Bouncer before, but we introduced additional PG Bouncer basically to split main and CI connections, basically. So we could now have basically CI specific PG Bouncer that we could say, okay, this is data reading from projects, it goes through main PG Bouncer. This is data reading from CI pipeline, so it's going through CI PG Bouncer. And phase 3 was effectively introducing CI PG Bouncer.
Yes, yeah. And basically phase 4 was like introducing another PG Bouncer, but this one is going to be for the GitLab CI table. So anytime you are writing to a GitLab CI table, it has to go to a new PG Bouncer, which was introduced different than the PG Bouncer for the GitLab main tables. Again, Arthur here, at this point, we are still writing to the same node, but just through different PG Bouncers. This is still phase 4. But the important thing about phase 4 here, if you see now, like anything that's related to GitLab main tables has to go through different set of database connection than the GitLab CI tables. Like if you are reading or writing to GitLab main, it has to go through this path here or this path here. And if you have to write to CI or read to CI, it has to go this one through this one, or also reading. I remove this arrow here. Okay, this is important because this is basically kind of like a more complicated version of what we are doing to self-manage at the moment for 16.0, which is like writing the code and supporting with test through two different connections, even if it's the same database. Like, look here, we are still writing to the same database, but through different connections. So from the application perspective, it's like two databases. We are simplifying the code to look like it's two databases, but it's basically the same database. This is going to help so much with the cleaning up the code and making it simpler. So phase 5 and phase 6 were basically about some validation steps. You can see that in the original epic, there was not much there. There was no actions, just to make sure that everything is fine, no errors. And this is where phase 7 came. Basically, that was maybe the most important event I have noticed at GitLab. This is something we have done. We have done several runs on staging just to make sure that everything is fine. We have done it maybe 5 or 6 times on staging before we said, okay, now we are ready to do it on production. So we did that on production on, I think, 2nd of July last year. Basically, we took GitLab down, no writes, no reads, nothing, no cyclic jobs. And then we promoted the CI. This is not GitLab CI, this is the CI cluster. So just to pay attention to the names. So we promoted this one. Once we promoted this one, there's no streaming from the original cluster. So now anytime you write here or write here, the data is different. And then we moved the PG bouncer, the one for the CI writes, we made it point to the new cluster, and then we started the application again. So the application now is just, if it's writing to the CI pipeline stable, okay, it's still writing to the same PG bouncer. From the application perspective, there was no change at all. And we are still reading the CI data from the new cluster. It's just the PG bouncer is pointing to a new cluster, and two clusters now are pointing, having two different data. I'm not sure if you have time after that, Arturo, like we can maybe take 5 minutes from the one-by-one call. And
yeah, go.
Yeah.
No problem.
Yeah, it took more than expected. If someone has anything, we are still recording it, so feel free to leave. This is again the phase where, like, okay, now we have two clusters and we have two databases, and everything was fine. But there's something important here. The GitLab CI tables here now contain still data. They still contain the data, but this data is not, we don't read from it, we don't write to it. And the same thing for GitLab main tables on the CI database. Like for example, CI on the users table that's here, okay? It's anyone signs up, the user is not going to be recorded here. So this is just all data that's not necessary anymore. It's just taking some space. So the idea later with the cleanup, which now we call it technical debt, that's the name we came up with 30 minutes ago. One of the issues that we wanted to do is that to clean up this data, and this is what we did also in some change request. This of course has been done already in that epic. This was important because we wanted to clean up the storage on these databases. So we did the truncation of the data on the GitLab CI tables on the main, and the GitLab main tables on the CI database. This is something we did on staging, and then later we did it on production as well in September and October. But there's something important here. We truncated these tables. We did not drop them, which means that these tables still exist. And the thing is, we still have the same schema between the two databases. Okay, so every time a database migration runs to create or drop or add a column or do anything, it has to do that on both databases. This is something we are planning for release milestone 18.0 so far. It might change, that we might make these schemas different, but at the moment it's the same. It's still the same schema. That's of course something for any database migration that changes the schema, but if this database migration that's changing the data, that's something different. You can read more about, like, there's a link for multiple databases development if you want to know more about what's going on, about also the GitLab schemas, because there's GitLab main, GitLab CI, GitLab shared, and there's also GitLab internal, which means all the internal tables of Postgres. Yeah, which again, there's also GitLab Geo, something that I did not cover here. It's outside of the scope of my presentation. GitLab Geo, we don't have it on GitLab. We don't have it on staging or production. It's only on self-managed instances. I already mentioned about this. Like we are bringing the decomposition for self-managed. Basically, at the moment, what we are doing with two connections. So from the application perspective, it's reading through different connections, but these tables, they can be on the same database, they can be on two different databases. Okay, the most important question, something that comes after the original time. How does this relate to cells? Okay, so this may be one of the reasons why I'm doing this this summary anyway. If you are following on the merge request that Camille is working on, we are introducing a new type of tables, something called GitLab main cluster wide. So we are taking some tables from the GitLab main and we are classifying them as GitLab main cluster wide. We are also removing all the foreign keys between the tables. We are also removing all the join queries and these things. But these tables at the moment are going to stay on the main database. The idea of these tables is that they are going to be shared between all the cells in the future. Okay, so the idea is that once we introduce cell 2, anytime cell 2 needs to read or write from these tables, it has to reference these tables on the main database of the cell 1. But GitLab main and GitLab CI are going to be split between the cells, so they are going to be related to the cells. At some point, hopefully, this GitLab main cluster wide is gonna reside on its own database. Once we feel okay, now they are ready and it makes sense to have them on their own cluster. But at the moment, maybe in the beginning, in the first phase, something that Camille, of course, can confirm, they are going to stay on the main database. That's basically it. That was the last slide. It was almost on time, but so close. I hope that helps. If you have any more questions, I had to rush through the slides at the end. If you have any questions, let me know. We can also answer them later. Anything? I hope no one is asking and they are muted. Okay, so I'm going to assume that no questions.
I think it was very helpful for me. I don't have a specific question now at the end, but yeah, I think, yeah, great presentation. So yeah, thank you very much.
Thank you. I hope that helps. I will stop the recording.